All right, guys, welcome to solving equations with variables on both sides. So equations are just statements about the equality of two expressions. The two expressions form the two sides of an equation and are always separated by an equal sign or an equality sign. So far, we have only worked with solving equations that have variables on one side, but today we begin to look at ones with variables on both sides. So let's look at exercise number 1. It says, consider the equation 5x plus 6 equals 2x plus 30. Notice how I have variables on both sides of my equal sign. When we have variables on both sides of an equation, we want to isolate the variable, meaning get it alone, get it by itself, before performing our do-undo method for solving two-step equations. So step 1, isolate the variable by getting rid of, and this is in quotations because that's not really a math term, getting rid of, but it's a term I'm going to use. Get rid of the smaller term. What I mean by that is I'm going to take a look at this equation and I'm going to find which of these variable terms is the smallest. So smallest can either be the smallest positive number, or if you think about it in terms of small as in negatives, if I had a -1, the larger negative is actually going to be the smaller number, but we're just working with positives right now. So I noticed that this 2x is obviously smaller than the 5x. So in order to get rid of it, I have to subtract it away. The reason why I'm subtracting it is because it's positive. So what will happen here, and remember, in equations, I always have to do the same thing to both sides. So if I'm going to subtract 2x from this side, I also have to subtract it from this side. Notice I'm putting it under the other variable term because we know, like terms, I can only subtract or add something to a like term. So since these are both variable terms, I can subtract them. Excuse me. So 2x take away 2x gives me nothing, right? Just 0. So all I have left is my 30, which is kind of what I wanted. I want to isolate the variable. I only want variable on one side. Right now I have it on 2. So now on this left side, I just have to do the subtraction. 5x take away 2x obviously gives me 3x. And I have my plus 6 still, and that is what my left side looks like. Now this equation looks like things that we were working on in the last couple lessons of just regular two-step equations. So it says now step 2, once a variable is only on one side of the equation, we can solve it using our two-step equation solving techniques, okay? So I've brought this equation down here, and now we're just going to solve it like a regular two-step, okay? If you would like to do your do-undo, go ahead and do that. I'm going to skip that for now because I think people are starting to figure out how to do that without the actual table. But if you need it, go back. But notice, the first thing that's happening to this variable is the multiply by 3, and then the addition of 6. So to do the opposite, to unravel this equation, I have to subtract 6 on both sides to start. So I'm going to subtract 6, okay? When that happens, 6 take away 6, those cancel out. All I have left is my 3x. Over on this side, I have 30 take away 6, which gives me a 24. Okay, my last step is to undo this 3 times x. The opposite of multiplying by 3 is dividing by 3. Okay, so I'm going to divide by 3 on both sides. And I'm showing you ways that you can make this look nicer, okay, by using the text feature instead of all drawing all the time. 24 divided by 3 is 8. So my answer for this complex equation that we started up here just ended up being x equals 8. Let's look at one more of these, and then you guys are going to try one on your own. So learning to solve simple equations with variables on both sides is the next evolution in your equation solving tool bag. Okay, so we're evolving. We're getting even further into our equation solving techniques. The next exercise gives you practice on all sorts of types. So in this solve the equation below, show each step. Your answers will be integers, but could involve negatives as well as positives. Okay, so this looks very similar to the one up here. Remember, my first step says isolate the variable by getting rid of one of the smaller variable terms, okay? So I'm looking at my 2 variable terms here. I have a 7n and a 2n. I'm going to get rid of one of them, and the one that I'm going to get rid of is the smaller one. So I notice 2n is the smaller one. So on both sides, I'm going to subtract 2n, okay? And notice how I'm lining up my minus 2n underneath the 7n, because again, those are the like terms. I can't subtract, I can't do 5 minus 2n. Those aren't like terms, I can't do it, okay? I also am subtracting because this is a positive 2n. My end result, I want these to cancel. If I had done plus 2n, well, 2n plus 2n gives me 4n. That doesn't make the n's go away over here. I want the n's to go away. I want this only to be a number over here. I want this to just be 25. On this side, I'm subtracting. 7n take away 2n should give me 5n's. And then I still have my plus 5. So 5n plus 5. And then my equal sign on my line. Don't forget your equal sign. Now I'm just doing my regular two-step equation. This is a plus 5. So the opposite of adding 5 would be subtracting 5. And I have to do it to both sides. Okay? So I'm subtracting 5. 5 minus 5 is 0. This 5n comes down. So I have 5n on this side with my equal sign. Over here, I'm doing 25 take away 5, which should give me 20. My last step, I have to undo the multiplication. So undoing a times 5 is dividing by 5. Okay, so when I finish out my equation here, I just have an n equals, which was I wanted. 20 divided by 5 gives me 4. So my answer for this complex equation here is that n equals 4. You guys are going to get a chance to try B on your own on the Kami. So head back to the Kami and try B.